Hello everyone. In this video, we are going to solve a CSES problem called 2 nights. In this problem, our task is to count for k equals to 1 to 2 up to n the number of ways 2 knights can be placed on a k by k chessboard so that they do not attack each other. So the constraint of n is at most 10,000. Okay, so let's start solving this problem. The first observation that we want to make is that in order to count the number of ways where we place 2 knights on the board so that they do not attack each other is equal to the number of ways to put all 2 knights in the chessboard subtracted by the number of ways where 2 knights attack to each other. So in order to count this, all we need is to count the number of ways they actually do attack each other. So the format of the problem also gives us some hint saying that in order to produce the answer from all the k values from 1 to 2 up to n, what we can do is we can think in an incremental way, right? So let's see. All we need is to count the number of ways where 2 knights can be placed on the chessboard so that they do attack each other. So let's try this. So suppose we are already given some answer that concerns a k minus 1 by k minus 1 chessboard. So suppose that we have already considered all possible ways to put knights in the upper left corner of the first k minus 1 rows and k minus 1 columns. So we would like to know what's the number of additional ways to put pairs of knights in this k by k chessboard such that they attack each other. So because of we're thinking of in an incremental way, we knew that if there is a new pair of knights that attack each other, one of them has to be on this strip in the last row or in the last column. So in this way, we can check this. So let's say, suppose we are in the first column and the last row. There we know that there is exactly one way. Exactly 2 ways depending on how large is k, right? So there could be 2 ways. There could be 2 ways for forming an attacked pair. And here, you should choose another color. Here, if we place in the second column, there could be at most 3 ways, right? And then for starting from the third column to there are 4 different ways, right? So the number of ways depending on the k values. If k is greater than 2, then we know that the number of new ways to put 2 knights that attack each other is starting from 2, and then we have 3 possibilities, and then we have 4 possibilities, right? Up to whatever, right? So this gives us some ideas on how do we actually count the new number of ways to put knights. So in this way, we should be able to formalize it and try to code it up. First, we add a new file. Then we read the input. Then for each k values, then we try to solve from the previous value to the current value, right? So number of ways they attack each other is total number of ways to count. Let's try to count the number of ways to put two knights on the chessboard so they attack each other. In particular, we want to count the case where the one knight is on the last roll of the chessboard. In particular, we can do this for different k values. For example, if k equals to 3, then the number of new ways to put chess is 2 plus 2 plus 2, right? Notice that this 2 here is different because unlike the case we had here, we do not have enough space for put an additional knights out of the range. So when k equal to 3, we have 2 plus 2 plus 2. When k equals to 4, we have 2 plus 3 plus 4 plus 2. When k equals to 5, we have 2 plus 3 plus 4 plus 3 plus 2, and so on and so on. Right? So starting from the 6, we have all the 4 in the middle, and so on. So now we can use this as to count as a new contributions of number of pairs of knights that attack each other for the whenever the one knight locates on the last roll. And by symmetry, we can have the same thing. The same count also holds when there is one knight that is on the last column. But we may have overcount things. So in particular, in the last two cells, let's see if we have one knight in the last row, but in the second to the last column, it may contribute the same pair. And we may have these 4 different pairs that are double counted in both last row and last column. So all we need to do is to subtract by 4 whenever we obtain the final sum. Okay, so let's try this. If k is, we only do this whenever k is at least 3, right? So in this case, if k is 3, we will add for example, like we say, we will have our last roll, the count when at least one piece of knights is in the last roll is at least, let's see, 2 plus 2 plus 2. Right, and if k is at least 4, then we know that the last roll is 2 plus 3 plus 3 plus 2, and if k is at least 5, then we know that the count is 2 plus 3 plus 4 times k minus 4 plus 3 plus 2. And then we have the same value, but the last column counts the additional count for the columns, right? So last row minus 4. And then we update our count equals to last column plus 1. Okay. And at the end, we want to output the number of pairs where they do not attack each other. Therefore, what we will do is to count the number of ways that equals to k by k chessboard, choose 2. So it's k by k times k by k minus 1 divided by 2, subtract the number of counts that we just obtained. So this is what we got. That should be. Let's try to do this. If we enter n equals to 8, we should print out the first 8 terms. So that should be the same. So let's try to upload it. And aha, it gets accepted.